right, we got them highlighted. Just a heads up, I put right angles in that diagram for you, but they're not in your, it's not a given that they're right angles. So keep that in mind. Okay, I marked it for you on the diagram, but that doesn't mean that's a given that they're right angles. Let's see what we have and what we need. AX congruent to AY, can I count those as a pair of sides in those two overlapping triangles? Look at the overlapping triangles you just highlighted. Are AX and AY sides in those two overlapping triangles we're proving congruent? Because I want to put an S next to it if it is. Can I count those as sides right there? Here we go. Connor, can I count those as sides?
Yes.
Yes, you can. Yep. Some of you guys were shaking your head no when I did that. Look, AX is a side in my yellow one. AY is a side in my purple one. All right, so take a look at yours. So we have a pair of sides. Two more pair to go, kids. Two more pair to go. It's already marked in the diagram, so can we take care of it right now? Those right angles? Okay, let's take care of them right now. Angle A, I don't want to call it angle X because there's a couple of them. AXC and angle AYB are right angles. How do we know they're right angles? Not because they're marked, that wasn't given. How do we know, John Carlo, what do we got? There you go. Got it? That doesn't deserve an A, though. That doesn't deserve an angle next to it because after you tell me they're right angles, what do we have to know about those right angles? Evelyn? Yep, congruent. And now, I don't know how, well, I do know how this is going to end, but maybe you don't, and it might end in HL because it's a right triangle, may end in HL. We wouldn't need this step, but it's fine if it's in there already. Might as well be on the safe side. And what if it's not an HL proof? You still need it. All right angles congruent. And that's an A. All right, so far we've been on easy street. One was given to us. Right angles are pretty easy for us. Now, usually this is where I have a lot of students sink. They can't find that third pair. They struggle to find the third pair. Struggle now. Let's go. Find the third pair right now. Where's the third pair of sides or angles? They're there. Okay, I think we got some. If not, I'll try to direct you to where it is here. Going deep here. Alex, got anything? All right, well, look at the two triangles you highlighted. Did you highlight anything more than once? Any full side or full angle did you highlight more than once? Oh, there it is. Right, everyone see it? Angle A is a full angle in both those triangles. Yes, it is, and I can call it angle A because it's the only angle there. So angle A is a shared angle. Angles can be shared just like sides, reflexive. All right, now it's just a matter of is the side in between or not, right? Is the side in between or not? Draw it out if you have to. My suggestion is always take one of those triangles, draw it out, mark the sides and angles you've marked on the original diagram, and see what method you have. It's not going to be HL here because I only have one side. I need at least two sides for HL. So this is not going to be an HL one. All right, got a method. Method, Nick. Side is in the middle. One more time. I always like doing this. A, X, C, draw one of them out. Here's my right angle. Here's reflexive A, and we mark side AX. That side is in between. Good. Anything else? All right, next one you're doing on your own for the assignment, due for homework. So we're going to number 3 right now to finish class. pencil noses rocking here. All right, let's talk. Part A is not too bad, but I'm going to need studs only on part B. Studs only on part B, so some of you may want to leave the room when we go to part B. All right, part A is not too bad. First up, I have AD congruent to BC. AD congruent to BC. Can I count those as a pair of sides? Are those sides in the two triangles you've highlighted? Can I count those as sides or not, Charlotte? Yes, you can. Thank you. So I have a pair of sides. Got it. I'm not even going to look at the other two because they're not sides or angles congruent. So I got a pair of sides. All right. Talk to me here. Where are my other sides or angles here? That's on you guys now. What do you got? Any sides or angles? Next up, Lucia. Good talk. That's embarrassing when I do that. Nick, other sides or angles? All right, we got a shared side that we highlighted twice. Put a little X there. Perfect, reflexive. And I'll put an S next to that. And one more pair somewhere, right? Somewhere. I think this one was that too bad, I think. Nick, again. What do you have in the givens? I need you to use the givens. You guys read it and write it and don't even pay attention to it. What's in the givens? Yeah, I know that. What else? There's more than that. What's that mean? Oh, you're killing me, boss. Killing me. What's perpendicular mean? Thank you. Where are the right angles then? Yep, and? Here we go. Angle DAB and angle CBA are right angles. Perpendicular lines form right angles. What do I still need to know about those right angles, regardless if an HL proof or not here? John Carlo, what do I still need to know about the right angles? Darn right they are. All right, can we just talk quickly here? How I'm going to eliminate it's not HL. What's the H and HL stand for again? I want to show you why it's not HL. What's the H stand for again, Taylor? Hypotenuse, which I told you is always located across from the right angle. Look at one of the triangles you highlighted. Look across from the right angle. Have we mentioned any of those sides at all? AC or DB? No. So you don't have the H. So forget about HL. You don't have the H. But I do have another method. Triangle DAB congruent to triangle CBA. And that method, why are those triangles congruent there, Evelyn? Side angle side. Good work. I don't think that was bad. I think most of us should be able to handle that in here. Okay. Woo! Buckle up for this next part. Proving EA and EB are congruent. Some of you, even if you're pretty darn good in here, some of you might want to go, oh, well, we just proved the triangle's congruent, so EA and EB are congruent by my little CPCTC. No. Here's why. Everyone look at EA, please. Lock in on EA. Is EA a side in one of the triangles I just proved congruent? No. It's smaller. It's smaller. So you can't say it's a part. It's not a corresponding part. So that's why they're not congruent by CPCTC. Understand that. Because EA and EB are not sides in the triangles we just proved congruent. Shoot. So it's just not going to be an. How are we going to get to EA and EB? Woo-hoo. Congruent. Let me give you a little push. Oh, you think you know it, Leah? Ooh. Let me back up. All right, Leah, I'd love to hear this. Go ahead. Okay, talk to me here so I can just knock you down again, but go ahead.
Like AC minus AE. Or what? AC minus BC.
All right, here you go, Leo. Ready? You're going to do dB minus DE.
Yeah.
Okay, whoa. Let me just write down what you're telling me here. dB minus, and I understand where it's coming from. dB minus DE equals, on the other side, you're going to go CA minus EC. Do I have that correct? Okay, you ready? When you do when you do subtraction, you need both pairs to be equal from whatever you're subtracting, right? Good? All right, here's my problem. I agree, Leo, that those two are congruent by CP/CTC because we just proved the triangle's congruent. So those parts are. What I can't have, though, is I have no idea if DE and EC are congruent, what I'm subtracting from them. So good there? Okay, I do like your thought of subtraction, but I just don't have enough information. Anybody else want to chime in, or did you just get scared because I took Leo? I took him down there. Addie?
Is the bottom, well, like the triangle in the middle, is that or
Say that again.
oh, wait.
EA. Name the triangle.
Oh, AEB.
AEB, and you just said, is it isosceles? And my response is, not yet. Not yet. Noah? Okay, what's getting cut in half? That's what I don't like. Where's bisector? Right? I don't have that like bisector. I don't have midpoint. Right?
The right angles
Okay.
would be half the right angle.
How do you know it's getting cut in half? Right? Okay, these are all good things here, and you guys are understanding here. I need some backup here. Sloan.
Supplements of congruent angles.
Okay, what's supplement mean? Angles that add to what? 180, right? We got right angles up there. Okay, we're getting there. I'm still on Addie's thought of, is the EAB isosceles? Not yet. Evelyn.
Angle CAB is congruent to angle DBA.
There you go. Okay, everyone ready? Name the first angle, Evelyn.
CAB.
Everyone look at CAB right now. Please lock in on angle CAB. Can we all agree that's in one of the triangles we just proved congruent? Yep, everyone, yep, this angle right here. It's in one of the triangles we just proved congruent. And Evelyn, name the other triangle, other angle you said. DB, everyone lock in on DBA. Lock it in on DBA. Isn't that in the other triangle we just proved congruent? So shouldn't those angles be congruent because they're in the congruent triangles? That's CP/CTC. Agreed? Agreed? These two angles have to be congruent because they're in the angles, they're in the triangles we just proved. Angle EAB, and this is tough, I know. I want to challenge it. EBA and EAB. Yeah. You could also name it A if anybody. You could also go DBA and CAB if you wanted to. That's CP/CTC. And let's go back to Addie. And what was your thought, Addie? Is it now? Why? Because it's got what? And everyone, what's across from the congruent angles? What's across from the congruent angles? Congruent sides. Okay, everyone see that this triangle EAB is isosceles. So across from the congruent angles are the congruent sides we needed. EA congruent to EB. In a triangle, congruent angles are across from congruent sides. A lot of good thoughts there. All right, but just don't throw out a theorem because it sounds good. You need backup. You need vocabulary terms to back yourself up there. Whew, good one there. Good one. I like it. I didn't need to give you anything there. You guys got that one on your own. And speaking of on your own, see ya. You guys got two more proofs to do here. Warren.
Where's point C on number 4?
Point C on number 4. CE. Oh, it's going to be where, yeah, how about that, huh? Let me go to number 4. Thanks, Warren. Here you go. C's up here. Okay, C's up there. Thank you. All right, let's do this. If you got somebody around you want to work with, feel free.